You hear about it all the time, from AI that completely dominates the world's most complex games to the tech that's behind self-driving cars. There's this incredibly powerful idea at work, and it's called reinforcement learning. Today, we're going to break it all down, and I promise by the end of this, you won't just know what it is, you'll actually get the simple core logic that makes the whole thing possible.
Yeah, does this sound familiar? Reinforcement learning, or RL for short, is one of those things that just seems to be popping up everywhere. But how it all works can still feel kind of like a magic trick, right? Well, you are in exactly the right place, because today we are pulling back the curtain.
You're probably thinking, okay, so it's basically about rewards and penalties? Kind of like training my dog. And you know what? You've absolutely hit the nail on the head. That's the core of it. But how does a machine go from a simple good job signal to making decisions that are truly complex? That's the big question we're about to dive into. All right, let's start with the absolute basics. What is reinforcement learning? Well, at its heart, it's a concept you're already super familiar with. It's all about learning from experience.
So here's the fundamental idea. Instead of feeding a machine a whole bunch of labeled data and saying, learn this, in reinforcement learning, we create something called an agent. We drop this agent into an environment, and it has one single goal: figure out which actions lead to the biggest possible reward. It learns completely through trial and error, basically teaching itself how to win.
And this brings us right back to that perfect analogy, the one that really makes this whole thing click. It is just like training a pet. You reward the good behavior, giving a treat when they set, and after a bunch of tries, your pet connects that specific action with that positive reward. RL agents, they do the exact same thing, just with data and algorithms instead of doggy biscuits. So if our little agent is out there learning on its own, what are the pieces that make it all work? Let's take a look under the hood and break down the essential building blocks of this entire system. Okay, so every single RL problem has these 4 key parts. First, you've got the agent. That's our learner, our dog. It exists within an environment. Think of that as your living room. The agent can take different actions, like sitting or staying or rolling over, and then, based on those actions, it gets a reward. That's the treat that tells it, hey, you did the right thing. But this really simple setup creates a massive, massive challenge. I mean, think about it. If an agent finds an action that gives it a pretty good reward, should it just keep doing that one thing over and over forever? Or should it take a risk and try something totally new, which could lead to an even bigger reward, or maybe nothing at all? This right here is the central dilemma in all of reinforcement learning. It's called the exploration versus exploitation trade-off. Exploitation is using what you already know to get that guaranteed reward. Exploration is trying something new on the off chance you discover an even better strategy. See the problem? An agent that only exploits will never find the best possible solution, but an agent that only explores will just wander around forever and never get good at anything. The real secret to powerful learning is striking that perfect balance. Okay, so how do we actually program an agent to find that balance and learn in a smart way? Well, it turns out there are a few different playbooks, or strategies, and each one has its own unique philosophy. We can pretty much group these learning strategies into 3 main flavors. Value-based methods are like a food critic. They try to put a score on how good every single action is from any given position. Policy-based methods are more direct. They're like a coach just telling you the next move to make right now. And then you have model-based methods, which are like a grandmaster in chess, trying to build a complete map of the entire game in their head so they can plan many, many moves ahead. Now, behind all of these different strategies is a really cool mathematical idea called a Markov decision process, or MDP. Don't worry about the name, seriously. The only thing you need to know is it's one beautiful, simple rule. What matters for your next decision is where you are right now, not the whole long, complicated path you took to get here. And that one little assumption is what makes an impossibly complex problem totally solvable. This foundation is what lets us build some seriously powerful algorithms. Deep Q networks, for instance, literally gave an AI eyes to learn how to play video games just by watching the screen. Policy gradient methods are kind of like a golfer who slowly, methodically perfects their swing over thousands and thousands of practice shots. And then you have actor-critic methods, which are even smarter. They have one part of the brain guessing the best move and a second part critiquing that move, which lets them learn incredibly fast. Okay, so that's enough theory. Where is all this cool technology actually being used and changing our world today? Let's get into the real-world impact of RL. In robotics, it's nothing short of a revolution. I mean, instead of a person having to painstakingly program every single tiny movement, RL lets robots learn for themselves. They can figure out how to navigate a cluttered warehouse or how to gently pick up an object they have never, ever seen before. Autonomous vehicles are another huge one. Before a self-driving car ever hits a real street, an RL agent can drive billions of virtual miles inside a computer simulation. It can experience every crazy weather condition, every possible traffic jam, learning how to react safely to everything, all before its tires even touch actual pavement. Of course, for a lot of us, the first time we heard about RL's incredible power was in gaming, right? When DeepMind's AlphaGo beat the world's best Go player. But those exact same principles are now being used in finance to create trading algorithms that can optimize strategies and manage risk by adapting to a market that changes every single second. And the potential impact in healthcare is just wow. It's truly profound. Researchers are now using RL to design personalized treatment plans that can actually adapt based on how a patient is responding over time. It's even being used to speed up drug discovery by having an agent explore millions of possible molecular designs to find the most promising ones. Now, as powerful as all this sounds, RL isn't some magic bullet. It comes with some very real, very tough challenges. So let's talk about the path forward, and maybe, just maybe, how you can take your very first step. You're going to run into a few big hurdles. First, RL agents need a ton of data. We're talking massive amounts of trial and error to learn something, way more than a person would need. Second, the training process itself can be really unstable and unpredictable. And finally, designing that reward signal is super tricky. If you get it even a little bit wrong, the agent might find a really clever but completely useless way to get the reward, kind of like a kid finding a loophole in the rules of a game. So to kind of put it all into perspective, maybe think of it this way. Supervised learning, that's for answering questions you already know how to ask. Unsupervised learning, that's for discovering brand new questions you didn't even know you should be asking. But reinforcement learning, that's totally different. It's all about teaching a machine how to achieve a goal through a sequence of smart decisions. Look, if any of this has sparked your curiosity and you want to get your hands dirty, the path is actually pretty clear. Start small. Play around with a classic learning environment like cartpole. Then try to implement a basic algorithm like Q-learning yourself. I'm telling you, when you actually watch the little agent get better and better trial after trial, that's when the magic really clicks. And from there, you can start moving on to the more advanced stuff. And really, that's the ultimate takeaway here. This whole journey of discovery, of learning through interaction, it isn't just for the AI agents we're building. It's for us too. Understanding how these systems learn helps us think better about how we learn. And that's a pretty powerful reward.